transducers. Now, a transducer is a device that receives energy from one system and transmits it into another. It provides a usable output in response to a specified input measured, which may be physical or mechanical quantity, property or condition. There are different types of transducers. Among one is thermistor. The electrical resistance of most materials changes with the temperature. By selecting materials that there are very temperature sensitive devices that are useful in temperature control circuit and for the temperature measurements can be made. Thermistor, also known as a thermally sensitive resistor, or non-metallic resistor, which is semiconductor materials. The thermistors have a negative temperature coefficient. The resistor decreases, it means that the resistance decreases with the temperature rises. Also, it is made by sintering mixture of metallic oxides such as manganese, nickel, cobalt, copper and uranium. From this graph we can find out that when the temperature is increasing, the resistance is decreasing. It's a temperature versus resistance versus temperature graph of a thermistor. The resistance at the room temperature for a typical commercial units ranges from 100 ohm to 10 mega ohm. They are suitable for use only up to about 800 degrees Celsius. In some cases, the resistance of the thermistor at room temperature may decrease by 5% for each 1 degree rise in temperature. The high sensitivity of temperature changes makes the thermistor extremely useful for precise temperature measurement, control and compensation. The smallest thermistors are made in the form of beads. Some are as small as 0.15 millimeter in diameter. This may come in a glass coating or sealed in the tip of a solid glass knob. The glass probes have a diameter of about 2.5 millimeter and a length which varies from 6 to 50 millimeter. The probes are used for measuring the temperature of liquids. The resistance ranges from 30 ohm to 10 mega ohm. Where greater power dissipation is required, obtained in the disc, washer or rod forms. Disc thermistors are about 10 millimeter in diameter, are used for the temperature control. Washer thermistors are made like disc thermistor. A hole is formed in order to make suitable for mounting a bolt. The disc thermistor, we know that it's only 10 millimeter diameter. Either disc thermistors are made by pressing thermistor material under several tons of pressure in round die to produce flat pieces 1.25 to 25 millimeter in diameter and 0.25 to 0.75 millimeter thick, having resistance values of 112 to ms. They are sintered and coated with silver on the flat surfaces. Now going to washer the thermistors. It is made like disc thermistor, except that a hole is formed in the center in order to make them suitable for mounting on a belt. The rod thermistors are extruded through the dies to make long cylinder units of 1.25 to 2.75 and 4.75 millimeter in diameter and 12.5 to 50 millimeter long. The leads are attached to the end of the rods. The resistance usually varies from 1 to 50 kilo ohm. Thermistors can be connected in series or parallel combination for application requiring increased power handling capability. High resistance units find applications in measurements that employ a low lead wire or cables. Thermistors are chemically stable and can be used in nuclear environments. The advantage of rod thermistor is the ability to produce high temperature units with moderately high power handling capability. Then thermistors are nonlinear devices over a temperature range, although now units with better than 0.2 degrees 2% linearity over the 0 to 100 degree temperature ranges are available. The typical sensitivity of a thermistor is approximately 3 millivolt per degree Celsius at 200 degree Celsius. Their wide ranges of characteristics also permits them to used in the ligament relegant limiting and regulation circuits and time delays for integration of power pulses and access memory units. A thermistor is one arm of Weinstein which provides precise temperature information. Accuracy is limited in most applications only by readout devices. Thermistors are the typical sensitivity of a thermistor is approximately 3 millivolt per degree Celsius at 200 degrees Celsius. Now these are the various configuration of thermistor. One has disc type, next the rod type and the washer type, and last one bead type. Now the circuit figure B shows that a bush type thermistor. Now coming to the advantages of a thermistor, it is a small size and low cost, fast response of narrow temperature ranges, good sensitive in the NTC region, which means negative temperature coefficient region, cold junction composition not required due to the dependence of resistance on the absolute temperature, contact and lead resistance problems not encountered due to large RTS or resistance value. Now it has some limitations such as non-linearity in resistance versus temperature characteristics, unsuitable for wide range of temperatures, very low excitation current to avoid self-heating, need of shielded power lines, filters, etc. due to high resistance. Now the next type of transducer is inductive transducer. It is maybe either of self-generating or passive type. The self-generating is a motion between conductor and magnetic field induces a voltage in the conductor. This relative motion between the field and conductor is supplied by a change in the measurement. An inductive electrochemical transducer is a device that converts physical motion into a change in inductance, change position change. The transducers of variable inductance type work on the following two principles: thus as the variation of self-inductance and the variation of mutual inductance. The inductive transducers are mainly used for the measurement of displacement. The displacement to be measured in arranged to cause variations in any of the three variables such as number of turns, geometric configuration, permeability of magnetic materials. Now for example, consider the inductive transducer has n turns and reluctance R. When a current is passed through it, the flux is phi is equal to Ni by R. Now taking differential, dou phi by dou t is equal, d by dt of phi is equal to n by 2 into di by dt minus ni by r square into dr by dt. Now that is equal to n by 2 into di by. Now if the current varies rapidly, it becomes n by 2 into n by r into di by dt. EMF induced in the coil is given by E is equal to n into dou phi by dou t, which means for E is equal to n into n by r into di by dt, that is equal to n square by r into di by dt. So the self-inductance is equal to EMF divided by EMF by di by dt. Therefore it is equal to n square by r. The output of the inductive transducer can be in the form of either a change in voltage or a change in inductance. It can be of two types, changing self-inductance with the number of turns. The output may be caused by a change in the number of turns. The linear and algebra Angular inductive transducers are used for the measurement of displacement of linear and angular momentum respectively. In both cases, as the number of turns are changed, the self-inductance and the output also changes. Yes, the other one is the transducer working on the principle of changed self-inductance. The inductive transducer, which works on the principle of the variation of permeability, causes a change in self-inductance. The iron core is surrounded by a winding. If the iron core is inside the winding, its permeability is increases. So the inductance also increases. When the iron core is moved out of the winding, the permeability decreases, resulting in a reduction of the self-inductance of the coil. This transducer can be used for measuring displacement. Now, these are the two types of transducer, thermistor and a inductive transducer. One is thermistor is used for the measurement of temperature coefficient, and the inductive transducer is used for the measurement of the displacement. Thank you.